All right, so number 6 is a nifty little algebra problem. It's not too tough. If let f of x equals x minus 3a over x minus 2b for constants a and b, if f of x equals, or f of 5 equals 0, we know that 0 has to be in the numerator. So we know that x minus 3a, well, f of x, so x is going to be 5. So we have 5 minus 3a is equal to 0. And then it says f of 3 is undefined. Well, to have a fraction undefined, the denominator must be equal to 0. So we know that x minus 2b is equal to 0. Well, x is 3, so we have 3 minus 2b is equal to 0. Great. We can solve these. So minus 5, so you get negative 3a is equal to negative 5, divide by negative 3, divide by negative 3, and you get a is equal to positive 5/3. Over here, same idea. Minus 3, negative 2b is equal to negative 3, divided by negative 2, divided by negative 2, and we get b is equal to 3 over, I have the hiccups again, 3 over 2. So now we know what a and b are. If we have f of 1/3, we just plug in 1/3 for x, and away we go. So we know that we have f of x, of 1/3 rather, is equal to, I'm going to use a thinner pen if I can, nope, is equal to 1/3 minus 3 times 5/3 over 1/3 minus 2 times 3 over 2. So I'm going to give myself some more room here. So 3 divided by 3 is 1. So obviously we get 1/3 minus 5. In the denominator, 2 divided by 2 is 1, so we get 1/3 minus 3. Well, we need to have a common denominator. So we want this over 3, multiply by 3, and so we get 15/3. 1 minus 15/3 is negative 14/3 over, same idea, multiply by 3, so we get 9 over 3. And so 1 minus 9 is negative 8 over 3. Now this fraction, this complex fraction, may look a little bit daunting, but it's really not. Remember, the fraction bar is just another way of saying divided by. So we have negative 14 over 3 divided by negative 8 over 3. Well, dividing by a fraction, you just multiply by the reciprocal. So we have negative 14/3 times negative 3 over 8. Oh, these cancel out. The negatives cancel out. So we get 14 over 8, which is equal to, well, they both share a factor of 2, 7 over 4. And that's my answer, 7/4. All right, for number 7 is it's kind of a confusing problem. So let me try to talk my way through this. So we have keys. So we have 3 sets of 3 numbers, and each set of 3 numbers has exactly 1 key. Okay, and it tells us that 2 and 3 must be one of the keys. And then it goes on right here to say that 5 and 7, they're in the same set and they're not a key. So these have to stay together right here, which leaves 13, 17, and 29. They're all in different sets. One of these numbers has to be the other key. 11 and 9 must be in a different set. Okay, great. And 13 must be with either 11 or 9. Well, that is our first real hint. because we know that 13 has to be with 11 or 9, which means it cannot be with 5 and 7 because 5 and 7 are a set. And we know 5 and 7 have to be with that other key. So we right now know that 13 is not the key. All right. 7 cannot be in a set with 17 as the key. Okay. Well, if 5 and 7 have to go together, and if they go together, 17 can't be the key. But that's not any good because 5 and 7 have to be with another key. So that means that this one is out as well. So that means we have to have 5, 7, and 29 all together, making 29 the key. Let's see if we have anything that contradicts that. 13 cannot be in a set with 2 as the key. Well, I can put 3 here and 2 so I can put 3 here and 2 over here. That's okay. 19 cannot be in a set with 29 as a key. Well, that's no big deal. We can put 19 over here. Sure, you can have that. And that would give this 11. Oh, now 11 and 19 are not together. And this has to have 11 or 19, so we're good. So we know that the set we're looking for is 5, 7, and 9. And so we're looking for the product of the three numbers. So we have 5 times 7 times 29, and we get, what am I doing? I want 5 times 7 times 29. And there we go. There we have our answer. All right. Now I'm going to skip over number 8 because it's far too long to be in a video with other problems. Let's go to number 9, shall we? All right, number 9. Noah is combining gummy bears and jelly beans in equal parts to create a mixture that he will sell. I might want to buy this because I like gummy bears and I like jelly beans. The bears cost him $20 for 8 pounds, while the beans cost $14 for 4 pounds. He wants his cost to be 40% of his selling price. At what price per pound should he sell his mixture? All right. So the trick on this one is we have equal parts, and we know that we have 8 pounds here. So we know that for the gummy bears, we have 20 divided by 8. And so that is going to be a grand total of $2.50 per pound. Okay, so that's the gummy bears. I hate that gummy bear song, but man, gummy bears taste good. All right, while the beans cost $14 for 4 pounds, so we're going to go 14 divided by 4. And so we know the cost for the beans, jelly beans, is $3.50 a pound. Okay. So our selling price is going to be for 1 pound, right? So that means for selling, if the jelly beans were $3.50 per pound, we're going to put half a pound into the mixture. So for half a pound of jelly beans, that's $1.75. Where for half a pound of the gummy bears, that's going to be $1.25. So all told, for 1 pound, it's going to be $3 to make our mixture. But that's going to be 40% of his selling cost. So that means some number times 40% or 0.4 has to equal $3. Okay, so if I divide $3 by 0.4, I get 750 cents, which is also known as $7.50. That one isn't too bad. Finally, the permutations problem. All right, so here we go. A permutation is a way of ordering things or figuring out how many different ways we can put things together where the order matters. So for example, this has a meaning to it. If I scramble the letters, it gives it a new meaning. So a permutation typically is going to go with numbers and letters because you change the order, you change the meaning. The equation for a permutation is n as in the total number, p for permutation, and r for your restriction. In this case, we want 5. So if this problem were nice and easy, all we would have to do would be to say that n is equal to 8, because there are 8 letters, and r is equal to 5, and that would allow us to then say 8 factorial over 8 minus, oh, I forgot to give you the equation. How horrible of me. The equation is n factorial over n minus r factorial. So in this easy situation, with a word that is not addition, we would just have to say 8 factorial over 8 minus 5 factorial, which is equal to 8 factorial divided by 3 factorial. But we can't do that because we have double D's as well as double I's. So we need to, I know, it makes it difficult. So what we need to do is we need to come up with some different situations. Let's talk about case number 1. Case number 1. Case number 1, well, we have 8. So let's say we have, for case number 1, exactly, let's say we have the A, we have a T, we have an O, we have an N, and we have exactly 1 D and 1 I. So in this case, we have no repeats. In other words, we don't have 2 D's, we don't have 2 I's. So in this case, with no repeats, we have 1, 2, 3, 4, 5, 6 numbers. So that's 6 factorial over 6 minus 5 factorial, which is equal to 6 factorial. Well, what is 6 factorial? And 6 factorial is equal to 720. So in case 1, we have exactly 720 options. Okay, so I'm going to write this up here so I give myself room. Well, if we have case 1, guess what? We're going to have a second case. So in case 2, let's say we have, oh, I don't know, we have both D's or both I's. So let's say we have A, D, D, so we're repeating the D's. T, O, N. 1, 2, 3, 4, 5, 6. And then we have no repeats for the I's. So in that case, oh, wait a second. Okay, so I'm going to get back to this problem. It's 5 o'clock and I need to go home. So you have the answers for 6, 7, and 9, and I'll make a separate video for 8 and 10 tomorrow. Okay, have a good night.